Welcome to the deep dive. Today we are on a mission to decode a very specific, highly technical artifact that I think offers an absolute masterclass in clean software architecture.
Yeah, it really is a masterclass.
It is. We're looking at a dispatch published today, August 21st, 2026, by a developer named Ang, and the title of this post is Notes-on-Haskell-Programming Part 219, Refactoring Parse Function to Use Application Monad.
Which is quite a mouthful, I know.
It is, yeah. But for our listeners out there who are always trying to learn and optimize, even if you have never written a single line of Haskell code in your life, this short post is just a goldmine.
Oh, absolutely.
We are going to extract some brilliant insights on managing state, preserving testability, and improving what we call developer ergonomics. So, okay, let's unpack this.
Let's do.
To really understand the brilliance of what Ang pulled off here, we kind of have to start by visualizing the core problem.
Right, the pain point.
Exactly. So imagine you work in this sprawling, massive corporate office building, and your job is to coordinate a highly complex project.
Okay.
But there is a catch. The fundamental rules for this project, like the deadlines, the client preferences, the strict security guidelines, they are all printed out and stuffed into a single, thick, red, physical file folder.
Oh, I see where you're going with this. Which means someone has to be responsible for carrying that physical folder at every single meeting on every single floor of that building.
That is the exact nightmare. Yes, you are lugging this red folder up, 3 flights of stairs just to hand it to the marketing team.
Right.
You wait for them to look at it, you take it back, you walk over to the accounting department, you hand it to them, and then you carry it all the way down to the lobby for the legal team.
It sounds utterly exhausting.
It is. And you have to do this just in case anyone in any of those departments needs to know what the overarching project guidelines are.
And frankly, highly prone to error too, right? Because dropping a page in the stairwell is a real risk. Or, accidentally handing the accounting team the blue folder from a completely different project.
Oh, man, yeah.
This logistical nightmare you are describing is precisely what software developers experience when they're forced to manually pass variables and arguments through every single layer of their code.
Yeah, Ang refers to this in the blog post as the manual grind.
The manual grind, yes. And this specific post is the final step in a massive, 219-part refactoring journey just to escape that grind.
So before we look at how Ang escapes it, I think we need to understand why this grind happens in the first place. Like, why would a developer ever design a system where they have to carry the proverbial red folder to every single function?
Right.
Why not just put the project guidelines on a bulletin board in the lobby where everyone can see them?
Well, that brings us to the fundamental constraints of functional programming languages, like Haskell. Because in a language like Python or JavaScript, a developer could just declare a global variable.
Sure. They could create a configuration object at the very top of their program, and any function anywhere in the code could just look up at that global object and read the file path or the debug settings.
So that's your bulletin board.
That is your bulletin board. But Haskell is a strictly pure functional language.
Meaning it refuses to let functions secretly look at global variables?
Precisely. In strict functional programming, a function is only allowed to know about the data that is explicitly handed to it as an input argument. It cannot peek at the outside world.
It's totally isolated.
Exactly. So in Ang's older code, which relied on something called the I/O monad, the developer was forced to manually pass the command line interface arguments, the CLI arguments, down the line from function to function.
Right, and the CLI arguments are basically the instructions for how the program should run, like which file path to read or whether to print out error logs, that kind of thing.
Right.
So because Haskell forbids global variables, the developer is forced to become that office worker carrying the red folder.
You have to pass those CLI arguments into function A, just so function A can pass them to function B, who passes them to function C.
And when you multiply that by dozens or hundreds of functions, passing those arguments manually clutters up the entire code base.
Oh, I bet.
The functions become harder to read and significantly harder to maintain. They're constantly juggling information they do not even need themselves.
Right, they're just acting as glorified delivery mechanisms for the functions further down the pipeline.
Exactly. So to solve this, Ang details a migration to a custom reader pattern monad, which is referred to in the post as the app monad. APP.
App monad. Okay, let's bring that back to our office building analogy. Switching to this custom app monad is like finally taking all the papers in that heavy red folder, scanning them, and putting them on a secure, restricted access company intranet.
Yes.
You don't have to carry the physical folder anymore. When a specific department, or in this case a specific function, needs to know the project guidelines, they're authorized to simply ping that shared digital environment.
That is a phenomenal way to visualize a reader pattern. It really is. It provides a shared environment that functions can read from without violating Haskell's strict rules by creating a messy, mutable, global variable.
Which is the dream, right?
Right. And we can see the mechanical reality of this shift in the code pipeline Ang provides. Previously, the pipeline code had to explicitly hand off the input path. But in the new pipeline, Ang uses a specific command to fetch that data.
Yeah, I'm looking at the post here. The command Ang uses is asks on vargs, ENVARGS. It sounds like the code is literally asking the environment for the arguments.
That is exactly what is happening mechanically.
Wait, really?
Yeah. The asks function is a built-in tool in Haskell's reader pattern. It reaches out to that shared intranet environment, the context the function is running inside, and pulls down the specific piece of configuration it needs.
Which in this case is nvargs.
Right. The pipeline code in the blog post shows how this results in incredibly clean calling code.
So I want to make sure the listener can picture this difference. In the old world, to run the parsing step, a developer would have to write out the function call and explicitly hand it the data at the end of the line. So typing out something like parse, open parenthesis, input path args, close parenthesis.
Well, you can visually see the red folder being handed over.
Exactly. But in the new code, the path argument is just gone from that top level.
Right.
It just says parse by content, vidual of avia. The args aren't there anymore.
Because the parse function itself now contains the instructions for how to log onto the internet and fetch the file path.
Ah, I see.
It removes the visual clutter from the pipeline, but the much larger victory is that it removes the mechanical burden from the developer who is stringing these high-level functions together.
They no longer have to worry about routing the data.
Precisely.
But here's where it gets really interesting. And I have to push back a little on this solution.
Oh, okay.
Because to make this intranet-like system work, to let the parse function fetch its own data, Ang had to actually change the internal wiring of the parse function itself.
That's true.
We are changing its type signature, which introduces a massive architectural dilemma regarding function purity.
It absolutely does. The type signature change is really the crux of this entire dispatch.
Yeah.
Let's walk through the diff Ang shared. We should start with the old code, which had a type signature for the parse function that looked like this. Parse, byte string arrow, file path arrow, either apper or pandoc.
Okay, let's define those terms so we are all on the same page. The signature is essentially a strict legal contract for the function, right?
Yes.
It says, if you give me a byte string, which is just the raw text content of the file, and you give me a file path, I will give you back an either apper or pandoc.
And for our listener, pandoc is just the universal document converter library running under the hood of Ang's program.
Okay.
And either is a classic Haskell concept that simply means the function will spit out one of two distinct things, a success or a failure.
Okay, so it will either return a specific apper because something went wrong,
Yeah.
or it will return a successfully parsed pandoc document. So it takes explicit inputs and gives an explicit output. And in the world of functional programming, that is a beautiful thing. That is what we call a pure function.
A pure function, yes.
It has no hidden state, no secret dependencies, and no reliance on the outside world. It just looks at what you hand it, runs some math, and gives you a result. It's entirely predictable.
Completely predictable.
But then we look at the new signature. Ang changed it to parse : byte string arrow app, and then in parentheses, either apper or pandoc.
Notice anything missing?
Yeah. The file path argument has been completely removed from the input side of the equation.
Right. And internally, the body of the function now asks inputPath.nvargs command to quietly fetch the path from the app monad environment.
Rather than waiting to be explicitly handed the path by the caller.
Exactly.
So here is my challenge. If functional programming praises pure functions precisely because they do not have hidden dependencies, isn't turning parse into a monadic action that secretly relies on this external app environment a massive step backward?
Well,
I mean, why on earth would we sacrifice that beautiful, predictable purity just so the calling code looks a little cleaner on the screen? Aren't we just sweeping the complexity under the rug?
what's fascinating here is that you have isolated the exact tension at the heart of all software architecture. You are highlighting the classic unavoidable trade-off between purity and convenience.
That's a real trade-off.
It is. Aang is making a highly deliberate design choice about where the responsibility of data fetching should live.
So Aang is deciding that the responsibility shouldn't live with the caller anymore.
Exactly. Getting the file name directly from the environment relieves the calling code from having to juggle that data. When you are constructing a massive pipeline of operations, reading a file, parsing it, transforming the data, writing it to a database,
Right.
you do not want every single step of that pipeline to have to manually route the file path. It obscures the actual business logic of your program.
Okay, I can see that.
However, your concern about sweeping complexity under the rug is incredibly valid. When a function depends on an external environment, even a strictly controlled one like the app monad, it loses its standalone purity.
Which makes it an absolute nightmare to test.
Oh, testing is a whole different story.
Right. Think about it from a quality assurance perspective. If I want to write a unit test for a pure function, it is the easiest thing in the world. I just handed some fake text, I handed a fake file path, and I see what it spits out. It takes 2 seconds.
Very straightforward.
But if the function requires this whole app environment to run,
Then your testing process grinds to a halt.
Yeah.
You would have to mock up an entire massive app environment. You would have to configure the dummy CLI arguments, spin up the virtual intranet, and inject it into the testing suite.
just to test one function.
All just to check if a basic text parsing mechanism correctly identifies a bold word. It is heavy, it is cumbersome, and quite frankly, it actively discourages developers from writing rigorous tests.
Which brings us to the most elegant part of this dispatch.
Yes, it does.
Because Aang's brilliance lies in how this exact purity dilemma is solved in the very next block of code. Aang clearly realizes you cannot just throw away testable purity entirely.
You absolutely cannot. If you lose pure functions entirely, you lose the primary benefit of writing in a functional language to begin with.
So to answer this dilemma, Aang introduces a brand new helper function. It is called runParse, and the type signature for this new helper function is, let me read it, runParse : file path arrow, white string arrow, either apper or pandoc.
Notice how remarkably familiar that signature looks compared to where we started.
It's identical. It is entirely identical to the old pure parse function. It takes the explicit file path, it takes the byte string, and it returns the explicit result. There is no app environment attached to it whatsoever.
Exactly. By doing this, Aang has successfully extracted the core, heavy-lifting parsing logic and encapsulated it inside this new runParse function.
So how does the main program actually use this helper if the pipeline is calling the new parse function?
The new monadic parse action, the one that connects to the app environment, now simply acts as a middleman.
Yeah.
It reaches into the environment, grabs the file path using that asks command, and then immediately hands that path and the raw content over to the pure runParse function to do the actual work.
I want to look at the exact line of code Aang wrote for this because it is so concise. It literally just says pure and then a less than sign and a pipe, and then runParse path content.
Let's translate that for the listener.
Yeah, let's break it down.
The runParse path content part is straightforward, right? It is executing our pure helper function with the data.
Right.
The symbol in the middle, the less than sign, followed by a pipe, which is often pronounced as the left pipe operator, or is sometimes written as a $sign in other Haskell code bases, that simply means take the result of the thing on the right and feed it to the thing on the left.
And the thing on the left is the word pure.
Yes. In Haskell, pure is a specific function that takes a normal everyday value and lifts it up into a monadic context. So runParse does the pure calculation, gets a plain result, and then pure wraps that result back up in the app monad so the rest of the pipeline can understand it.
That is just so elegant.
Really is.
It is the definition of having your cake and eating it too. You are completely isolating the mechanics of fetching data from the mechanics of processing data.
Which creates a perfect division of labor. By extracting the actual parsing out into runParse, Aang ensures that a pure, stateless function is always readily available.
So for the main application, when the software is actually running in production, you get the ergonomic ease of the app monad.
Right.
The calling code doesn't have to carry the heavy red folder. It just lets the middleman fetch the data from the intranet.
Yep.
But when it comes time for the developer to run tests,
when you are testing, you completely ignore the monadic parse function. You bypass the middleman and the app environment entirely.
oh, that's great.
You just write your tests against runParse directly. You maintain that pristine, easy-to-test, pure function where you just pass it explicit inputs and check the outputs.
So you do not have to boot up the whole company intranet just to run a microsecond unit test.
Exactly.
Okay, so what does this all mean? We have explored the mechanics of migrating away from the manual grind of the I/O monad.
Mm-hmm.
We have looked at how the reader pattern acts as a shared environment, and we have seen how to protect our pure functions from being swallowed by that environment.
Right.
But we really need to zoom out and arise at the overarching philosophy here. Because if the old manual way technically worked, why go through the headache of a massive 219-step refactor to rebuild the entire pipeline?
That is the pivotal question. And Ang actually concludes the post by spelling out the exact architectural payoff of this entire journey.
But
It isn't just about saving a few keystrokes.
let's quote the dispatch directly then.
Yeah.
Ang states that retrieving input paths directly from the app monadic environment ensures a single source of truth and guarantee consistency.
Single source of truth. That phrase is practically the holy grail in software engineering.
It really is. Let's break down why that is the ultimate payoff for a developer.
Yeah.
Because it goes way beyond just making the code look neat on a monitor.
Right. Oh, absolutely.
Ang specifically notes that this new architecture actively prevents the calling code from accidentally passing a mismatched or hard-coded path string to the parse function.
If we connect this to the bigger picture, this entire refactor is a masterclass in defensive design.
Defensive design, I like that.
Yeah, good code architecture isn't just about making the machine run efficiently. It is about designing systems that anticipate human fallibility.
Right.
You have to build structures that make it mathematically impossible for tired, rushing developers to make silly mistakes.
Like hard-coding the wrong file path because you were trying to debug something quickly at 2 a.m. and forgot to change it back.
Exactly that scenario. Because in the old system where you manually pass the file path from function to function, there was absolutely nothing stopping a tired developer from bypassing the CLI arguments entirely.
They could just type out a raw string like c:/temp/document.txt and pass it straight into the parse function.
Right. To use our analogy, they could hand the function a completely different red folder that they just made up on the spot.
And the pure function wouldn't know anybody?
Not at all. A pure function doesn't question where its data comes from. It just blindly parses whatever path it is handed.
Wow.
But by forcing the top-level parse action to fetch the path itself directly from the strictly controlled app environment, the environment becomes the absolute authority.
There is no way to sneak a fake file path past it, because the caller doesn't even have the option to pass a file path anymore.
The input parameter is literally gone.
You cannot provide a mismatched path if the system structurally rejects your ability to provide a path at all.
It guarantees consistency across the entire pipeline. Every single function in the program that needs the input path is getting it from the exact same authoritative source.
The envarg stored securely in the app monad.
Yes. No one can go rogue.
Okay, this has been an incredibly insightful journey through just a few lines of code.
It really has.
We started with the sheer manual grind of the I/O monad. The exhaustion of carrying that physical file folder to every function, because Haskell forbids global variables.
Yeah.
We saw Ang leverage the reader pattern to create the app monad, acting like a secure company intranet. We tackled the very real dilemma of losing function purity, and saw how brilliantly extracting the logic into the run parse helper saved our ability to write easy unit tests.
A very elegant solution.
It is. And finally, we arrived at the ultimate goal, establishing a single source of truth that makes mismatched data errors virtually impossible.
It is a phenomenal refactoring strategy that balances practical ergonomics with theoretical purity. But analyzing this architecture raises an important question that I think we need to leave lingering for anyone building these kinds of systems.
Being honest.
We just spent this time celebrating how moving data into a shared app environment prevents callers from passing mismatched data. It forces everyone to use the approved intranet, but at what point does a heavily loaded reader environment just become a glorified, highly complex global variable?
Oh, wow. That is a dangerous tipping point.
Right. If you start putting absolutely everything into the app monad just because you want to avoid passing arguments manually, how do developers ensure that their perfectly pristine single source of truth doesn't eventually rot into a single source of unmanageable clutter?
That's a great point.
Where exactly do you draw the line between essential application-wide environment data and variables that really should just be explicitly passed the old-fashioned way?
That is a phenomenal thread to pull on. It is like we took all those physical file folders and dumped them onto the intranet to save time, But if we aren't highly disciplined, that intranet is just going to turn into a disorganized digital dumping ground where no one can find anything.
Exactly.
It's a vital warning about over-engineering. Something to think about the next time you are tempted to just hide your arguments in the environment to make your screen look cleaner. Let that percolate until next time.